Hi, 7th graders. Today we're going to be talking about dependent events. So we've been discussing probability the past few days, and so now we're looking at what we call compound events. So this is when we have more than one event happening, and you can have independent events, which independent events can stand independent of each other. They don't affect each other. This could be something like rolling a number cube and spinning a spinner. So just two completely separate events. Or it could be having a collection of items, pulling something out, putting it back in, and then drawing a second time. But we also have something called dependent events. So dependent events are where we have two or more events where the outcome of one event does affect the outcome of the other. And so we're going to look at some situations here. We'll talk about if they're independent or dependent and why. And then we'll find some dependent probability for some different scenarios. So if we're flipping two coins and they both land on tails. So if we're flipping two coins, those two coins, whatever I flip on the first coin, does not affect what the second coin can land on. And so those would be independent events. If I select the captain of the soccer team and then I'm selecting a co-captain, this would be like where I have a group of individuals. I'm going to choose one. And so now when I've chosen that first one, that changes my total number of outcomes of what's left to choose from. And so that first event affects the second. So that's going to be a dependent event. Drawing the queen of hearts from a deck, then a joker, since it's not specifying anything specific there, as far as if we are replacing it, we're going to assume that we did not replace it, so that's going to be dependent. Number 4, pulling a white sock from a box, replacing it, then a black sock. So this is a good example of if I pull something from a collection or a bag or a box, I pull it out, I put it back in, that essentially resets that whole situation. And so that does not change the probability, so these would be independent events. And then pulling a white sock from a box, not replacing it, then a black sock, that would be, since I'm not replacing it, I'm now again changing the number of possible outcomes that are left, and so that would be dependent. So we're going to be figuring out dependent probability by multiplying the probability of each event happening. We're going to figure out the probability of the first event, and then the probability of that second one after the first one has already happened. And so we'll look at some examples here, and hopefully that part will make more sense. So here it says Polly goes to a dessert buffet shown below. She chooses one dessert, then another. So it's like you're going up and you choose two desserts. Okay, so what's the probability that she selects a cookie, then a piece of cake? So right now I have 5 cookies out of 10 total desserts. Okay, I know that 5/10 is going to simplify to 1/2, so that'll end up actually being the probability that I use there. Okay, now because this is a dependent event, I'm gonna try to visually do this. Let's pretend she takes that cookie. Okay, so if she takes that cookie and we're gonna look at what's left, well, now we have 8 desserts left. Oops, I'm sorry, 9 desserts left. And so to get that piece of cake, she has 9 options. 3 of the 9 that are left are cake. So she has a 3/9 chance of picking a piece of cake. And so that fraction can also be simplified to 1/3. And then now we can multiply those two probabilities. So when we multiply 1/2 times 1/3, we can multiply straight across and get 1/6. What's the probability that she selects a cupcake and then a cookie? So we're going to look at the probability of selecting a cupcake. And so I have 2 cupcakes out of the 10, which is equal to 1/5. And then again, we're going to pretend that, okay, she has the cupcake, so to get a cookie, we now have 9 options left, and 5 of those are cookies. So we're going to be multiplying 1/5 times 5/9, which gives us 5/45, and we can simplify that to 1/9. And then the probability that she selects 2 cupcakes. So we actually already figured out the probability of 1 cupcake, or the first one being a cupcake. So the probability that the first one is a cupcake is 2/10, which again was equal to that 1/5. Now, assuming that she picks a cupcake, if we look at for that second item to be a cupcake, there's now only 1 cupcake left out of the 9 possible outcomes. So we're going to do 1/5 times 1/9. Again, this 1/5 came from the 2/10. So think 2/10 times 1/9. So both the numerator and denominator actually decreased there because it was the same item. So when we multiply straight across, we have 1/45. So she has a 1 in 45 chance of randomly choosing both cupcakes. Number 2, Mrs. Jones puts the letters mathematics in a bag, so each of those is like on a separate sheet of paper. She draws a letter, does not replace it, then draws a second letter. What is the probability of her drawing an M and then an S? So again, we need to make sure during these probability problems that we're reading each question carefully. So when I read this, something that sticks out to me is that she's not replacing the letter back in. Okay, so we want to look at the probability that she pulls out an M and then an S. So first, to figure out the probability of pulling out an M, I'm going to look, and I see 2 M's. So I know she has 2 opportunities to pull an M out of, if I look at all of the total letters here, there are 11 total. All right, so she has a 2/11 chance there. And then we're going to imagine that she pulled an M, okay? And so now we're thinking about, okay, what would be her chances of getting an S? So when I look at the word mathematics, I only see 1 S here. So there's only 1 opportunity there. But now because we have the M already and we're not replacing it, there's now only 10 outcomes left. And so when we multiply straight across here, our simplified final answer would be 1/55 or 1 in 55. Number 3, Hayden takes 2 pieces of candy for a snack. What is the probability that he takes 2 pieces that are not candy corn? So first of all, over here, it looks like we have a total of 8 pieces of candy. And so if I want to know the probability that the first piece that he grabs is not candy corn, there's 2 candy corn, which means that there's 6 that are not candy corn. So he has a 6/8 chance there. And so then the probability that that next piece he grabs is not candy corn. Well, assuming that the first one wasn't candy corn, now there's going to be 5 pieces left that are not candy corn out of 7 total pieces. So I could go ahead and multiply straight across and then simplify my answer. When I see the fraction 6/8, I know that that's going to simplify to 3/4. So I'm actually going to use the simplified version. Multiply straight across, and we get 15/28. That was a little bit about dependent probability. Remember to please be asking questions if you need any clarification. Have a great day.